Hello everyone, this is Sonu Chauhan and you are watching me on your favorite YouTube channel, that is Byju Exam Prep. In this Ground Zero series, we are going to discuss a very important topic for all the mechanical engineer, that is thermodynamic work done. In this topic of thermodynamic work done, we are going to cover the basic concept, basic idea behind the thermodynamic work done. When we say that work is done on the system or work is done by the system, then what exactly the meaning behind it? And after that, we are also going to relate these all the thermodynamic terminology with the PV diagram and the generalized formulation of this work done for the closed system. So these all important points we are here to discuss related to thermodynamic work done for a closed system. And this thermodynamic work done, you know very well, is a very important concept for the basic thermodynamic. So let's start this topic. When you see from the very basic concept, when this piston is moving forward or backward, then in that condition, if I'll ask that work is done by the system or work is done on the system, then what is that work done? First question. Second, what is the difference between the thermodynamic work done and the mechanical work done? So, as this piston is moving forward in this particular direction, you can feel, then this piston is displaced by some fluid. So, we can simply say that energy is transferred from this fluid to the piston, or there is the complete displacement of the piston in the direction of the pressure applied. So that's why if we define the thermodynamic work done, so we can define the thermodynamic work done in the next page, that what is this thermodynamic work? Work is said to be done by the system when the sole effect on the thing external to the system, or you can say surrounding. Whenever the sole effect of the system on the surrounding is equal to raising the weight, means whenever you are going to apply any force on the system, then it is something like that weight is raised by the system, then in that condition we can say yes, it is the example of thermodynamic work. Let's move forward. Weight may not be actually raised, but its equivalent effect should be raising of the weight. So I think from these all the words or definition, you are not getting the exact point. Let's try to understand the same concept with a very simple example of this thermodynamic work done. Generally, at this particular point, we are having the electricity, or you can say electrical battery. After the battery, a motor is connected, and after that, this is the fan. I think this type of complete system you have seen a lot of time. A battery is connected with the motor and motor is then rotating a fan. So in that case, can we say it is the thermodynamic work done? And if it is the work done, then how can we define or how can we connect this entire system with our definition of the thermodynamic work done? That work said to be done by the system if the sole effect of the system on the things external to the system is raising the weight. And here in this case, we are really feeling that weight is not raised by the wings of the fan. Because when you will just switch on this electricity, then shaft will start to rotate. And when this motor shaft will start to rotate, then fan will also rotate into your room. So in that condition, weight is not raised, but work is done by the system. Do you know why? Because if you will focus on this bracket term, then it will give you the more detailed idea that how the work is done by the system. What we can do in this case, let's try to replace these wings of the fans with the help of a pulley. Let's see on the next page, this entire fan wings are replaced by a pulley like this. This one is a pulley, and pulley or this rope is connected with the pulley, which is more connected with the weight. So in this case, we can say the same electricity battery, same motor we are having here, and we have just made a small change that the wings of the fan is replaced by the pulley, and the rope is wrapped over the pulley, and after that it is connected with a weight. Now let's see the equivalent effect. Means weight may not be raised in actual, but its equivalent effect should be like this. So now when you will just switch on this battery, then your motor will start to rotate like this. And when your motor will start to rotate like this, then your pulley will start to rotate in the same direction. Your pulley will start to rotate in the same direction like this. And when your pulley will start to rotate in the same direction, then we can simply say my weight is raising into the upward direction. Are you not feeling in the bracket term? That weight may not be raised in actual condition, but its equivalent effect should be raising the weight. So in that condition, we can say either you take the example of this fan or you take the example of this pulley, then definitely work is done by the system. So by replacing the equivalent system, you will get the clear-cut idea when work is done by the system or not. After that, let's try to discuss few more important points. In this work done, a system or you can say boundary play a very important role. Because if I'll ask to a mechanical engineer that what type of work is done in this case, then maximum of the mechanical engineers will say that, sir, mechanical work is done by the system. Mechanical work is done by the system. Do you know the reason? Reason is very simple, that when a mechanical engineer is going to focus on the system, then he is going to consider the outlet of this entire motor as a system. This as a system he is going to consider as a mechanical engineer. That's why he see, because the shaft is rotating, that is the reason this is the example of the mechanical work. But at the same time, if I'll ask the same thing with the electrical engineer, then he can say that work is the electrical work. Do you know the reason? Reason is very simple. He is going to consider this as a system. Means between the boundary and motor he consider a system, and flow of the electron is the work done in this case. So he can say yes, in this case it will be the example of the electrical work. Even the phenomena of both the figure is absolutely same. In the first case, the same phenomena is there. In the second case, even it is the replacement, but you can say it is the same phenomena. So if I'll ask what is the difference, then difference is only that is the consideration of the system. As a mechanical engineer, we are going to consider output of the motor as a system, and as the electrical engineer, we are going to consider flow of the electron as a system. So in this case, this play a very important role, that is known as boundary. So unless we are not going to decide the boundary of the system, we are not going to decide actual meaning of the work done. So before starting to generalize, to formulate the formula of the work done, we must know for which type of system we are going to define the thermodynamic work done. Or in the other word, we can simply say that you must define the system first, and after that we need to define the work done. If we simply talk about the motor output, then work done will be the different in type, and if we are talking about input of the motor, then work done will be different. So again, before writing the answer related to the work done, you must know for which type of system, for what particular system we are going to calculate the work done. So we can simply say that work done is a boundary phenomena. Unless we are not going to define the boundary, we are not going to deciding the nature of the work done, type of the work done. So one thing very important, we can say that work is a boundary phenomena. Let's come to the second point. If we switch off the battery, if on this particular example we switch off the battery, then motor is not rotating, fan is not rotating, even pulley is not rotating. Is weight lifting in the upward direction? Absolutely not. So if the weight is not lifting in the upward direction, is it the work done? Not. The amount of the work done when the battery is switched off is zero. But is it there any type of energy in the battery? Yes, it is the chemical energy. It is the chemical energy. So we can say that work cannot be done by the system or on the system until unless it is in a process. Whenever everything is in stop condition, everything is in equilibrium condition, work is not done by the system or on the system. That is the reason. Secondly, we can also conclude a very important point, that work is also the boundary phenomena as well as the transient form of energy. In general, we know very well that there are two types of energy. One is stored form of energy, like chemical form of the energy we can store. Internal energy we can store, but mechanical work or thermodynamic work we cannot store. That exists only when it is in transition, when it is in process. So you can simply say right now, if the system is in one equilibrium condition, then work done is zero. After a certain time, if system achieve the second equilibrium condition, then on that second equilibrium condition, work done is also zero. But in between the equilibrium 1 and equilibrium condition 2, what process is conducted by a thermodynamic process, that and only that is the condition to do the work done, either by the system or on the system. So we can conclude one more point from here. Work is a boundary phenomena and work is a transient form of energy. It is not the stored form of energy. If you want to do the work done, then definitely there must be some change in the system, right? After that, let's try to understand what exactly the meaning of the sign convention. Generally, we can simply say that if there is any system, then there are two types of the work sign convention we can define. What are these? Either work can be done by the system or work can be done on the system. For example, if I am going to decide the system, these are the boundary of the system. These are the boundary of the system. In the system, gas is filled. So whenever heat will be supplied to the system, whenever heat will be supplied to the system, then this gas will try to expand. Then this gas will try to expand. And when this gas will try to expand, this will try to apply the force on the piston. Things external to the system. That's why we say that what system we have assumed that is done, that what system we have assumed that is doing some mechanical work. So you can say in that condition, when gas is expanding and it is doing or applying some force on the piston and piston is moving in upward direction, that is the work done by the system. Means system is doing the work itself. We can utilize this mechanical work that is done by the system in some other form, whatever we want. Let's try to understand the same thing in other way. Right, in the starting, the gas is somewhere like this at this position. What we are doing, we externally applying some force on this system so that this piston is moving downward. Piston is moving downward, and due to the piston moving in the downward, we are going to apply some force on the system. On the system means these gas molecules. We are going to apply some force on the gas molecule. So in the previous one, whatever we have seen, in this case, gas has applied the force on the piston. That's why work is done on the system. And in this case, we have applied the force on the system. That's why this is work on the system. And in general, work on the system, we generally write as a negative term. Work on the system, we generally write as a negative term. So when externally we have to do something on the gas or any particular system, we can simply say that work is done on the system, that will be taken as a negative. And when we say system is doing something, and we can take the advantage of that work done to do any activity external to the system, that is the work done by the system. Right? So in this case, I think sign convention of the work done is already clear to all. What is the meaning of the work done on the system and why the system, right? After that, let's try to discuss some important point related to main thermodynamic topic, that how will you define the generalized form of thermodynamic work done for a closed system. Generally, we know very well that if we take the example of the closed system means piston cylinder arrangement. This is the piston and cylinder arrangement we are going to feel here. So in this case, one thing is very clear, no valve is there. That's why it is the example of closed system. Is it or not? It is the example of closed system. Clear? Yes. It is the example of the closed system. So whatever we are going to drive the thermodynamic work done for a closed system after that. Now, the gas is filled already in this chamber at a pressure of P1 like P, and after that on this piston one stopper is attached like this in the starting. So right now you can say it is maintained in the equilibrium condition 1. Right now it is maintained in the equilibrium condition 1. And at this point the position of this piston from this 0, 0 is x1, right? After that, what we do, we try to change, because work will be done whenever there will be change in the system. So if you want to change in that system, we can simply say that these stopper is removed, and when these stoppers are removed, then system reach somewhere here, that is the second position. So system reach from station 1 or equilibrium state 1 to equilibrium state 2, and at any particular point where the arbitrary length is x or the dx, if I just want to write what will be the value of the work done for this small displacement, can we write the work done for this small displacement, that is equal to force, already we have discussed, into displacement in the direction of force. Is it or not? Displacement in the direction of force. After that, if what is the value of the force? If P is the pressure, then value of the force we can write that it is P into A into dx. And we know very well, because cross section area of this piston is constant, dx is the length of the piston displaced by the gas. So what is this? This will be the change in the volume. So we can write from here that work done can be written by P into dV. If we want to find what is the total work done from 1 to 2, we can simply say that is 1 to 2 into PdV, like this. So what is this? This will be the total amount of the work done for a closed system undergoing a reversible process. Why reversible process? We are going to assume total inside pressure is converted into the mechanical work, right? So this is the work done that is valid for a closed system, that is valid for a closed system and undergoing a reversible process, Is it clear to all? Yes, undergoing a reversible process. Let's try to discuss the same thing on PV diagram. If I will represent the same change of pressure and volume, then at state 1 we know very well that pressure was very low. If I'll just draw the 2D diagram, then pressure was very low, and as long as the piston moving in the forward direction, piston moving in this particular direction, then pressure is going to decrease, your volume is going to increase. So in this case, if I consider the same change of volume, we can simply write the area of this small portion, that dA can be written by P into dV. And if I just want to find the area between 1 and 2, then area between 1 and 2 can be written by integration of 1 to 2, that is P into dV. Are we not feeling that right hand side of this diagram or this expression is same as we have discussed in the work done? So can we write that area under the curve when projected on the volume axis is it nothing but it is the work done for the closed system, that is valid for a reversible process only. That is valid for the reversible process only. Yes or no? So from here we are having two important points. One, the formula of the work done can be written by 1 to 2, can be written by 1 to 2 into PdV, and second, it is also written as area of PV diagram about the volume axis. And from this, after that, if you see then total amount of work done for any particular process, it is a very similar to the integration. Because if I will give you the condition between the pressure and volume like x and y in the calculus, then you will be able to find the area of that particular portion. That is the reason you will be able to find the value of the work done for that particular process. So just only one thing is required to give you, that what is the relationship between the pressure and volume for the different process. You will be able to find the value of the work done for these all different processes. So this is something about the work done you have got from the lecture. So I think you have understood each and everything whatever we have discussed in this work done topic. See you again in the next lecture. Thank you all. Take care. Bye-bye.